Hello everyone, my name is Ayush Kumar. My USN is 1BE23 Series 022 and I'm from third semester from the Department of Computer Science Engineering. My section is Aryabhatta. The subject code is BCS 303 and today's subject is operating system and today's topic is application of scheduling in processing of the operating system. Let's get started. Let me brief you about the introduction to scheduling. In the realm of operating system, scheduling plays a vital role. Operating system is basically the interface between the user interface and the kernel, and there are several scheduling algorithms which are the heart of this process, which determines the order in which the process are executed, thereby influencing the overall performance and responsiveness of the system. This presentation will also go into scheduling and different types of algorithms which we use for it. So let's get started. So these are the contents which are going to be covered in this, which are the first one is types of scheduling algorithms, which includes FCFS, SJF, and round robin. And there are a few algorithm comparisons. And finally, the main topic, which is the real world applications. So first we'll start with applications of scheduling. So there are six applications which I have taken. So the first one is CPU scheduling. CPU scheduling basically is the sequence and allocation of CPU time to process enhance CPU utilization, which also includes algorithms such as first FCFS, SJF, and round robin for pair distribution. As we have memory scheduling. In memory scheduling, there are various type of memory allocation and scheduling which prevents conflicts and optimal memory usage. Now, there are also fragmentation by efficiently swapping data between RAM and disk. There is the third one, which is the real-time scheduling, which is also application which ensures highest priority gets the task done within the deadline, especially in systems where time is very crucial, like for example, medical devices or automotive systems. Next, we have algorithms like rate monotonic scheduling, which also helps to see that the real-time scheduling is on point. Next, we have input-output scheduling. In input-output scheduling, there's mostly input-output device usage, which reduces wait time for the input and output, enabling faster access to peripheral like printers, keyboard, and external drivers. Next, we have network scheduling. In network scheduling, there is also the main thing which users expect as the latency to improve. So improving the network performance overall, which basically goes into the balanced network bandwidth allocation to different processes, especially in high traffic scenarios like cities, like the metropolitan city. And next we have disk scheduling. In disk scheduling, there is also a thing called read-write speed, which is very crucial for it. So if there is a scheduling involved in this and there is a certain algorithm for it, then it would surely reduce the time for it. Uh, Next, we have a few scheduling algorithms, which is FCFS, SJF, and round robin. So in FCFS is basically first come first serve basis. So in first come first serve basis, they basically arrive like a queue. It's easy to implement, but can lead to longer wait time for short jobs if a long job arrives first. Next, we have short job first, in which there are two types, primitive and non-primitive. So basically, it minimizes the average wait time but requires knowledge of the job's length beforehand. Next, we have round robin, which there'll be certain quantum time for it. So at that quantum only it will be running. For example, if the quantum time is 3, so it will be running at that quantum period. Like if the quantum time is 3, then it can't go for a four four timer process. It will be a set of three timer process. So we'll go further. So there is a small example. If the job one arrives first, it immediately enters the ready queue for FCFS, and it goes on for next job two arrives. Then job two also goes to the queue, and it will be executed as soon as job one finishes. Same happens with job three. Next we have SJ, which is short job first, in which we have primitive. So in primitive, basically, it is a scheduling algorithm in which it prioritizes the job with the shortest remaining processes. So that basically means here you can see there is an example of four processes. There is a arrival time. So here what happens is basically P1 goes first, then it will be at t equals 1. It will be completing one of its process. So the burst time would be 8 minus 1, which is 7. Next at arrival time 1, there is a insertion of P2. So it will compare between these two. So as we have showed here, which is shortest remaining process. So it will compare between these two, and whichever is the lowest, which is for in this example is P2, it will P2 will run, and after that in P3 there will be insertion. It goes on like that. Next we have SJF non-primitive, in which basically it happens is we have a small example in which job 1 arrives with a processing time of 10 ms, the scheduler makes it as ready. Job 2 arrives with a processing time of 5 ms, the scheduler prioritizes job 2 and begins its execution as it is lower than job 1, so the shortest job would be finished first. Same goes with job 3. Job 3 would be doing the job after job 2, and job 1 would be done last as its burst time is highest. So next we have the round robin scheduling, in which there will be a certain fixed quantum would be given, in which it will be running at that particular instance. It is a circular execution in which the round robin fashion with the scheduler cycling through the ready queue. Context switching: when the time quantum expires, the current job is interrupted and the scheduler switches to the next job in the queue. We have a small example. For example, there is a job 1 with a quantum time of 6, job 2 with 4, job 3 with 2. So here what happens is basically job 1 runs for only 2 ms because the quantum is 2. So it will be running at 2 to 2 intervals. It can't go beyond that. So that's how it goes on. If there is an insertion, the insertion would be running first, then it will be continuing like that. So it goes on like that. So there's a summary of this. We have learned various algorithms and applications in which there was FCFS, SJF, round robin, and there were also applications related to uh, disk and other things, which basically includes the read and write speed and other things, which is very crucial for optimizing system performance and ensuring efficient resource allocation in various computing environments. So that's it for the video. I hope you like the video. Thank you.